With the Bro Light Source Library, we can import a model, both physical and radiometric, of a wide range of commercially available light sources. In particular, we're going to look at an Osram LED, part number LAW5SF, and we're going to look at the process for bringing this information into ASAP, including generating the rays from this source, as well as creating ASAP script files that will help you use this within your current design or any future design you might choose to create. So I'm going to select first the source, and what this will also allow me to do initially is to look at a model of it. It tells me that this is a top-lead Osram LED, and if I click on View Model, it tells me some information about the axis. So the axis runs through the LED body, and the center origin of the coordinate system is at the dye location. And we see that it has a rated output of 24,000 millilumens, or 24 lumens, while running at 400 milliamps. And there it tells us which part sheet to look for more information. So what I'll do now is go through the process of bringing this information into ASAP to create a file. So I'm going to click on the Next button, and the first thing I'm going to do is to create and save a ray set. And I can choose whatever number of rays I wish to use. For our purposes, we'll stick to 10,000. And I want to give that ray set a name, and I'm going to give it the same name, of course, as the source itself, so I can keep track of the information. If, for instance, I wanted to offset this data, I'd indicate that in my ray set name, so if I need to use it multiple times, I'll know exactly what my source distribution was created from. And I will give it a rated flux, and let's just stick with the 24 lumens, and we would tell ASAP in the script file that we were dealing with lumens rather than watts. So let's continue. So ASAP is bringing in the geometry and calculating the information necessary to help generate the ray set. Now I can indicate which wavelengths I want to use. I can either take a spectrum of wavelengths, or I can simply take one wavelength. In this case, I'll take one wavelength, the peak wavelength, or somewhere in that vicinity. If I decide to change it to a more specific number, for instance, 595, I can edit this dialog box as well. Now, if I wanted to use multiple wavelengths, for instance, if I had a broadband LED, then ASAP would proportionately weight the rays in the different files for each wavelength so that the energy distribution was appropriate for the selected wavelengths. But for the demonstration purposes, one wavelength will be sufficient. Now I'll just click on the Finish button, and ASAP is going to go through and generate the ray set. Now, there are two pieces of information we see now. The first is the representation of the LED within ASAP, and you can see how physically accurate the model is. We can also look at the energy distribution plot in flux per steradian, and as we can see, it is somewhat Lambertian, limited, of course, by the small number of rays we've generated. Normally, you would want to trace hundreds of thousands or even millions of rays, depending upon your particular application. But now that ASAP has generated and saved this particular ray set, we have two choices. We can enter the data ourselves in our ASAP script file about this particular source, or we can have ASAP generate some source code for us directly and save that source code so we can use this file over and over again. I'm going to choose the second option. And to do that, I need to select my light source again, selecting the same bulb model. And this time, I'm going to select the option to write ASAP script commands to a template file. I'll click on Next. I'm going to give my template a name, and again, I'm going to name the template after the source itself. Now what I can do is tell ASAP where I want that source positioned relative to the coordinate origin of my system. I could also choose to rename the secondary axes. If I need multiple copies of this same source within my design, for instance, if I needed 7 or 8 LEDs positioned within my optical system, I can do that all right here by simply putting in the appropriate coordinates. For example, if I wanted to put 4 LEDs in a cross pattern, I might say that I've got an X position of 5, and then I'll add another one for a total of 4, and then I'll put one at a position of -5, and then here at a position of 5 and -5. Now what I'll need to do is tell ASAP what ray set to use, and because I'm always using the name of the source, it's easy for me to enter that information, and I need to enter it each time. Now I'll need to tell which ray file I want associated with each of those. So I clicked on the ray file column, and because of the base name I've provided, this is the file that was saved. This was my wavelength, and it was approximately a 10,000 ray set. So I'm going to add that ray set file, and I need to do that again for all of my sources. So now I'm going to have ASAP create for me a script file that will position the same ray distribution at 4 separate locations. And let me just click on the Finish button, and we'll just save that data. And this is what the template file would look like. ASAP will open the library to go to the ASAP directory that has the information about the physical model of the source, and it will place that geometry at 4 separate locations, and it will also place the ray sets at those locations. What this allows me to do is to either choose to include or not include the geometry when I'm doing my ray trace and analysis. But to make sure I get the proper analysis in the end to take into account any near-field effects, I would want to make sure that geometry is properly positioned. This is what's called a template file, and if I click on the little template icon here on my menu bar, I can see that I now have a template named LAW5SF. So anytime in the future when I want to use this template or the information about this ray set, it's available for me and I don't have to regenerate it. Let's take a look at the results. So I'm going to just run the file, and we will look at the 4 source positions and the rays coming from those sources. And now let's take a look at where the rays are. And I'll look in the YX plane. And most of the rays are coming directly up from the die of the LED, but there are others that are interacting with the dome and the reflecting cup itself. So now we have 4 LEDs with 4 energy distributions, and again we can use this in any of our optical systems. To use it in ASAP with the template file, let me just open up a new input window, and if I go to my template library and select my template and just click on OK, it will automatically be inserted in my script file at the location of my cursor.